Good morning. I am Shelly Singla from GPC Kuni Majra. Today my topic is scalar and vector quantities, their properties and examples. So first of all, we will start with the definitions of scalar and vector quantities. All the type of physical quantities are of two types. First is scalar quantities and second is the vector quantities. So the scalar quantities are the quantities which are having only magnitude but no direction. These are have only magnitude only but no direction. The examples of scalar quantities are mass, length L, time T, speed V, area A, volume V, temperature which is denoted by T. So all these are scalar quantities. The scalar quantities obey simple rules of algebra, which means they are added, subtracted and multiplied by the simple rules of algebra. Now the next is the vector quantities. Vector quantities are those physical quantities which have both magnitude as well as direction. The quantities which represent both the magnitude and direction are called vector quantities. For example, displacement is denoted by S vector. Remember that all the vector quantities are represented by a symbol and an arrowhead. The second example is velocity. Velocity is denoted by V and arrowhead. Acceleration, A vector. Force is F vector. Remember that force is equal to mass into acceleration. Mass is scalar quantity, whereas acceleration is vector quantity. Multiplying mass with acceleration, we get force, which is a vector quantity. Momentum, P vector. This is equal to product of mass and velocity. Impulse I vector is equal to F into T. Force into time vector, force vector into time. Electric field, E vector is equal to F vector. upon Q. F is the electric force and Q is the charge. Dividing force by charge is equal to electric field. So all these are the examples of vector quantity. Remember that vector quantities are added, multiplied and subtracted by special rules of vector algebra. So these quantities follow the rules of vector algebra. So this is the definition of scalar and vector quantities. Now we will see how a vector quantity is represented. Representation of a vector. How a vector quantity can be represented? Remember, any vector can be represented by a line. This is the line and an arrowhead. The length of this line gives the magnitude of the vector and arrowhead gives the direction. This is the initial point A and this is the end point or final point B. So this vector can be written as AB vector. We can also represent a vector by P vector. So this P vector is simply line with an arrowhead. The magnitude of any vector is represented by AB is the vector. If we have to take its magnitude, then we take it as AB vector. It represents the magnitude of vector AB. This can also be written as simply AB. So AB is the magnitude of any vector and AB arrowhead is a vector quantity. This we have to remember. Now the next is various types of vectors are there. We have to explain the different types of vectors. First is the negative vector. As this name suggests, let we have a vector A. This is the starting point A and this is the end point and the vector is AB vector. So negative of this vector can be taken as, if we take the same length as that of AB vector but the direction is opposite, then we take it as BA vector. This point is B and this is A. So this is the negative of a vector. BA vector is equal to minus AB vector. Any vector which have same length as that of the original vector but the direction is opposite is known as negative vector. Now the second is equal vectors. Two vectors are said to be equal if two vectors have same length or magnitude and same direction, then the two vectors are said to be equal. Let This is the first vector, which is p vector, and we have another vector which is q vector. Now the length of both vectors is same as well as the direction is same, so we take p vector is equal to q vector. Also we have to remember that the magnitude of p vector p is equal to the magnitude of q vector, which is q. So these are the equal vectors. Now the third type of vector is the unit vector. As this name says itself, a unit vector is a vector having unit magnitude is called a unit vector. It is denoted by, it is denoted by cap, p cap. Suppose we have a vector p vector and we have to take its unit vector, then the unit vector of this p vector is denoted by p cap. It is equal to the vector itself divided by its magnitude p. This can also be written as p vector upon magnitude of p vector p. Remember, in case of Cartesian coordinates, in case of coordinate system, this is the x-axis, this is y-axis, and this is z-axis. This is origin. If we take a unit vector along the x-axis, then it is taken as I cap. In the direction of y-axis, a unit vector is written as j cap, and in the z-axis the vector is denoted by k cap. So I cap, j cap, and k cap are the unit vectors along x-axis, y-axis, and z-axis respectively. So this we have to remember. I cap, j cap, and k cap are the unit vectors along x, y, and z-axis. Now the third is, next vector is null or zero vector. A null vector or zero vector is denoted by zero cap, zero vector. It is a vector which have zero magnitude and arbitrary direction is known as null vector or zero vector. This vector have no physical significance. This vector is having no physical significance. Now the next is the co-initial vectors. Two or more than two vectors are said to be co-initial co-initial if they have same starting or initial point. Let we have three vectors A, B, C vector, and this is the common origin point of the three vectors or initial point O. So these are the co-initial vectors. The next is the co-linear vectors. Two or more vectors are collinear. Two vectors are collinear if they are parallel to each other, anti-parallel to each other, or along the same line. Let we have vectors P vector and Q vector. These vectors can be equal or unequal in magnitude, but if they lie along the same line or if they are parallel to each other or if they are anti-parallel to each other, they are known as collinear vectors. Now the next is the coplanar vector. Coplanar vectors. Two or more vectors which lie in the same plane are called coplanar vectors. This is the plane of blackboard. If some vectors are lying in this plane, this is A vector, B vector, C vector, D vector. All these vectors lie along the same plane of the blackboard, so these are known as coplanar vectors. Now the next is the resultant vector. This is denoted by R vector. Resultant vector is the single vector, a single vector which produces the same effect as the individual vectors together do. Suppose we have a number of individual vectors A vector, B vector, C vector. We have 3 vectors and they can be represented only by single vector, which is R vector. So, this is called resultant vector. This will produce the same effect as these individual vectors will do together. Now, next is the vector algebra. As we have stated earlier that vectors follow the rule of vector algebra. They can be added, subtracted and multiplied, but they follow the rules of vector algebra. First is the addition of two vectors. Let us suppose we have two vectors along the same line. Let we have two vectors. First is the A vector and second is B vector, and they lie along the same line. So, if we have to add these two vectors A and B, A vector plus B vector gives rise to equal to resultant vector R vector, and this R vector is equal to the magnitude of both A and B, and the direction of R vector is same as that of A vector as well as B vector. R vector is equal to A vector plus B vector. The magnitude of R vector is equal to A plus B. Let us suppose A vector has magnitude of 5 meter and B vector's magnitude is equal to 3 meter. Then the magnitude of R vector is equal to the magnitude of vector A and magnitude of vector V, which is equal to 5 plus 3 is equal to 8 meter. Means the length of R vector is 8 and its direction is same as that of A vector and B vector. Now, we take the second case. If A vector and B vector are in opposite direction, let us suppose the A vector is along this direction and B vector is opposite to the A vector. Both vectors are opposite to each other and we have to add these two vectors. The resultant of two vectors R vector is equal to A vector plus B vector. Now, adding these two vectors, we get R vector. Its magnitude will be, R vector's magnitude will be equal to magnitude of vector A minus magnitude of vector V. In this picture, we can see that the magnitude of vector A is more as compared to the magnitude of vector V. So, the magnitude of vector R is equal to A minus B, which means A minus B, and its direction is as that of the vector A. So, this is the R vector. Now, Now we take the third case where A vector and B vector are at any angle to each other. We have vectors A and this is vector V, and these are along any angle to each other. Now these two vectors can be added by the two laws. First is the triangle law. Of vector addition. Another similar law is the parallelogram law of vector addition. Suppose we have to take this triangle law. So in case of triangle law, we take the two sides of triangle A vector and the second vector is B. So these two vectors represent the two sides of the triangle. Firstly, we have taken the triangle A and place the vector B on the end point of the vector A. The angle between the two vectors is theta. After that, we complete this triangle. Now the third side will give the value of resultant R along the opposite order. In the opposite order, the vector A is along this direction and B is along clockwise direction, but the direction of A is along the clockwise. A and B are in anti-clockwise direction, R vector is along the clockwise direction. So R vector is equal to A vector plus B vector. This is the triangle law. If we have to take the magnitude of R, this will be equal to magnitude of A square plus magnitude of vector V square plus 2A into B into cos theta and whole square. So this is the magnitude of the resultant vector according to the triangle law of vector addition. Now I will explain the parallelogram law of vector addition. We take the same vectors A and B. We have to add these vectors by the parallelogram law. Now in this case, we take first the vector A and place the vector B on the starting point of the A, so that the starting point of two vectors coincide with each other. Now we complete the parallelogram. Whole parallelogram is completed, and the diagonal of this parallelogram gives us the direction of resultant R. The angle between A and B is theta. R vector is equal to A vector plus B vector. Remember, the result produced by the triangle law and this parallelogram law is always same. It gives the value of resultant same in both cases. The magnitude of R is equal to A square plus B square plus 2AB cos theta whole root. So this we have to remember. We can also find the angle between this resultant R and the first vector A. Suppose this is beta B, so this we can also be calculated. Now after addition we take the subtraction